Hello everyone, welcome to my YouTube channel. I am Dr. Injimamula, currently working as an assistant professor at the Department of Mathematics, School of Computer Science and AI, SR University, Warangal. Today we will discuss the topic sampling from a finite population, introduction to the estimation. This lecture is very important because it forms the foundation of statistical inference, which is widely used in research, engineering and data analysis. In this session, we will mainly focus on the concept of interval estimation and how it helps us to deal with the uncertainty in real world problems. By the end of this lecture, you will be able to understand what interval estimation is, then interpretation of confidence interval correctly, and finally also we will solve some problem for mean and proportion. So let's begin. Let me ask you a simple question. Suppose I take a sample and calculate the average marks as a 75. Do you think the true population mean is exactly 75? Most likely answer is no. There always be some error due to sampling. So instead of saying the answer is 75, a better statement is the true value lies somewhere between two numbers. That is where the interval estimation comes in. So let's begin with the definition. The interval estimation is a statistical technique which is used to estimate a population parameter by providing a range of plausible value. Unlike point estimation which gives a single value as an estimate, the interval estimation offers a range within the true parameter is expected to lie along with a specific level of confidence. Okay, so let's discuss how this concept is used in the real life. For example, in a signal process, suppose we want to estimate the average noise level in a communication system. Instead of giving a single value, we say with 95% confidence noise lie between minus 97 dBm to minus 93 dBm. In the similarly, the another example for structural engineering, the estimate average compressed strength of concrete with 95% confidence, the true strength will lie between 28 MPa to 32 MPa. So here we saw that the real life example of interval estimation. So now we will define the confidence interval. The confidence interval for a population parameter is an interval computed from the sample data such that with a given level of confidence, that is suppose that 95% or 99%, the interval is expected to contain the true value of the parameter in this interval, right? So let theta be a population parameter and theta cap is its point estimation. Then the confidence interval is generally of the form we can write as a theta cap plus minus margin of the error, and this margin of the error will depends on the three things: the standard error for the estimation, and the second thing is the critical value from the sampling distribution, and third things depend on which the margin of error depends is the confidence level. Okay, so now here is something very important and also commonly misunderstood. What is that? What does a 95% confidence interval means? Okay, so let me explain this carefully. Okay, it means if we repeat the sampling process many times, then about 95% of the interval construct we will construct the contain the true population parameter. What is the meaning? The 95% of the interval we construct will contain the true population parameter. Now here is the catch. It doesn't means there is 95% probability that the true value lie in this interval. Okay, so this is a very common mistake. Instead it means the method is reliable note that a particular interval has the probability. So don't get confused that this 95% confidence interval means the probability on that interval. Okay, so only this means that the 95% of the true data of this population will be lie on that interval. So this is all about the confidence interval. This is the meaning of 95% confidence interval. Okay, so now we will discuss about the confidence interval for the normal mean. So now we will discuss about the confidence interval for a normal mean. We will find it in the two way: when the standard deviation sigma is known and when the standard deviation sigma is not known. When the standard deviation sigma is known, in this case the confidence interval Ci is given by, this is x bar, this is the what, this is the theta cap, and this is the what, marginal error. This marginal error is depends on what, the standard error. This is the standard error. So when the standard deviation sigma is known, in this case Ci equal to the x bar plus minus z alpha by 2 sigma by square root of n. So whenever we will find the interval, we will write like this one: x bar minus z alpha by 2 sigma by square root of n, comma x bar plus z alpha by 2 sigma by square root of n. And this x bar is what, sample mean, and already we have discussed about that thing. Sigma by square root of n is a standard error. So we can see here that this marginal error is depends on the standard error, right? So this is the sigma by square root of n is the standard error. So whenever the sigma is known, we'll use this formula to finding the confidence interval. And also we can see that the z alpha by 2 is the critical value from the standard normal distribution, and this will be given in the table. And alpha equal to 1 minus confidence level, and this confidence level also will be given in the question. Okay, now we will discuss to finding the confidence interval for a normal mean when the standard deviation sigma is unknown. First we will discuss it for the small sample, then we will discuss about it for the large sample. Small sample means what? Whenever small sample means what? Small sample means the total number of observations should be less than equal to 30, right? And if n is greater than 30, then we can say that the sample is large. Okay, so whenever standard deviation is unknown, there will arise two cases: either it will be for small sample or for the large sample. For small sample, we will use the t distribution. The confidence interval Ci is given by x bar plus minus t alpha by 2 comma n minus 1 s by square root of n. So whenever we write this one as an interval, we can write this as a in this way, right? So here we can see that this x bar will be what, simple standard simple mean, and s is what here, s is the simple standard deviation, and t alpha by 2 n minus 1 is the critical value from the t distribution, and we will provide these things in a question with n minus 1 degree of freedom. Okay, and for the large sample, to finding the confidence interval, we will use this formula: Ci equal to p cap plus minus z alpha by 2 square root of p cap into 1 minus p cap by n. Here p is the sample proportion and n is the sample size. So this is all about the confidence interval for a normal mean. There will be two cases: one whenever standard deviation is known, another is when standard deviation is unknown. For whenever standard deviation sigma is unknown, in this case there will be two cases will be arise: one for the small sample, another for the large sample. Small sample means what? Whenever the total number of observation is less than 30, and whenever the total number of observation for the sample size is greater than 30, in this case we will use the confidence interval by using this formula. Okay, so this is all about the formula for finding the confidence interval for a normal mean. So now let us understand this concept by solving some numerical problem. Now let us take an example based on the confidence interval. First question, suppose that when a signal having value mu is transmitted from a location A, the value received at location B is normally distributed with mean mu and the variance 4. To reduce error, suppose the same value is sent 9 times. If the successive value received are 5, 8.5, 12, 15, 7, 9, 7.5, 6.5, 10.5, let us construct a 95% confidence interval for mu. So in this question we can see that the sigma is given here. What is sigma? Sigma is given here. Sigma equal to what? Square root of 4. That is 4. In this question, sigma is known, and also we can find the sample mean. And here the level of confidence is given 95%. So by using the formula, whenever sigma is known, we will find the confidence level, right? Or confidence interval. Sorry, we will find here the confidence interval. So in this question, what have to find? Here we have to find the confidence interval. To finding the confidence interval, we will use this value, critical value from the Z distribution table. This is the Z distribution table. In the by using this value, we will find the Z alpha by 2. Okay, because in a question it will be given the level of confidence. With the help of this level of confidence and this formula, we can find the value of Z alpha by 2, and from this table we will use the value of Z alpha by 2. Okay, so now we will solve the problems. So here in this question, what is given? N equal to 9. So this will be sample size or large size? This is the small sample, right? Okay. And what is the sample mean? X bar will be what? If we add all the value, that is x bar is equal to 5 plus 8.5 plus 12 plus 15, 15 plus 7 plus 9 plus 7.5 plus 6.5 plus 10.5 by 9. If we add all these value, we will get that 81 by 9. So this will be equal to the 9. Okay. So this is equal to 9. What is the value of standard deviation? What is the value of standard deviation? Sigma equal to what? Square root of variance, that is 4. So this is equal to the 2. And what is the level of significance? Level of significance, confidence level of significance is given to you. Confidence level of significance. What is this? This is equal to 95%, that is 95 by 100. So what is the value of alpha? Alpha equal to 1 minus, this is C, this is 95 by 100. So we can write this one as a what? 5 by 100, this is 0.05. Okay, so this is the value of alpha, and from the previous table we can find the value of Z alpha by 2. This will be equal to what? Z 0.05, and this will be equal to 1.96 from the what? Critical value from the standard normal table. So this is the value of 1.96. So now by using this value, we will find the confidence interval, and we will apply the formula whenever the standard deviation sigma is known. Okay, so now apply the formula. First we will find what? A standard error. First we will find a standard error. What is this? A standard error SE will be equal to sigma by square root of n. So this is sigma is what? 2, and this is what? 9. So 2 by 3. then we will find the marginal error. We will find the margin of error. Margin of error. So that will be equal to what? Z alpha by 2 into standard error, into a standard error. So this is equal to the what? 1.96 into 2 by 3. So this is almost equivalent to 1.31, right? So now we will find the confidence interval as a what? Now confidence interval equal to what? Confidence interval equal to x bar plus minus e, right? So this is equal to the what? This is the marginal error. Already we have discussed about this formula. So x bar equal to what? 9 plus minus e equal to what? 1.31. So if we write this as an interval, we can write as a 9 minus 1.31 comma 9 plus 1.31. So whenever we solve this, we will get that 7.69 to 10.31. What does it mean? That means the 95% confidence interval for the population proportion is lie between this interval 7.69 to 10.39. So we can write as a, this can be written as what? The 95% confidence interval for population proportion is what? 7.69 to 10.31. Okay. So this is all about the first problem. Okay. So now we will discuss another problem. A teacher want to estimate the average score of student in a final statistics exam. She select a random sample of 9 students from her class and record their score. The sample has a mean score of 78.2 and a sample standard deviation of 4.5. Then in this question, construct a 95% confidence interval for the population mean exam score. So here we can see that the standard deviation is not given here, right? And here n equal to the 9, that is less than 30. So we can say that this is a small sample. Okay. So by corresponding to that, we will use the formula to finding the confidence interval. Okay. So let us start the solution for this question. Okay. So what is given here? Sample size n equal to the 9, right? So this is what? Small sample. Okay. Now sample mean is also given here. Sample mean, that is x bar. This is equal to what? This is equal to 78.2. And also sample standard deviation is, sample standard deviation is equal to what? 4.5. And the level of confidence, is what? 95%. So what is the value of alpha? 1 minus 95 by 100, again it is equal to 0.05, right? Since here we can see that since n is less than 30 and sigma is what? Sigma is unknown. Sigma is unknown. We use the formula involving t distribution. Involving t distribution, right? So now, what is the degree of freedom? That is n minus 1. Degree of freedom, this is equal to what? N minus 1. and n is equal to 9, so this is equal to 9 minus 1 is 8. Then critical value from the t distribution. What is the critical value from t distribution? T distribution, that is what? T of alpha by 2 comma n minus 1, this is T of 0.025 to 8. Okay, so this is equal to what? We can find this value from the table as we have earlier discussed. So this is equal to what? 2.306. Okay, now what is standard error here? Standard error SE will be equal to what? Will be S, because here sample standard deviation is given. That's why we will use S by square root of n. And S is equal to the what? 4.5 here, and n equal to what? 9. So this is equal to the what? 4.5 by 3. So this is 1.5. This is 1.5. So now we will find margin error. Margin of error. What is margin of error? Margin of error equal to the what? This is E equal to T into 0.05 to n minus 1, that is what? 8 into standard error. So this is equal to the what? 2.306 into standard error is what? 1.5. So this is equal to what? 3.459. Okay. So now what is the confidence interval? Confidence interval equal to what? X bar plus minus E, that is margin of error. So this is equal to the what? X bar equal to what? 78.2 is given it is, and this is equal to what? 3.459, right? So we can write this on as an interval that will be equal to 74.741 to 81.659. What does it means? We are 95% confident that the true average exam score lie in this interval, lie in this interval. Okay, so this is all about a problem whenever the sample space is small and standard deviation is not given. Okay, so come to the next problem. There is another problem. In a political survey, 420 out of 600 randomly selected voters said that they would vote for a candidate A. Then construct a 95% confidence interval for the proportion of all the voters who support candidate A. In this question, we can see that the n equal to the 600. That is the large sample space, and also here the standard deviation is not given here. Okay, so that's why we will use the formula for the proportion, right? So now we will solve this problem as a, what is given here? Here given, we will find first sample proportion. Sample proportion, that is what? P cap. This is equal to what? 420 by 600. So this is equal to the what? 0.70, right? Sample size. Sample size. What is here? Sample size. Sample size n equal to the 600. So this is what? Sample size 600. So this is what? Large sample space. This is what? Large sample space. Okay. And level of significance is what here? Level of significance C equal to what? 90%. That is 90 by 100. This is 0.9. Okay. And so we can find the value of alpha. Alpha equal to 1 minus, we will find the alpha equal to level of significance. This is 0 by 9. So this is 0.9. So this is equal to what? 0.1. So Z alpha by 2 that is z 0.1 by 2, we can find this value from the table. This is 1.645. Okay, so now we will apply the formula as we have discussed for the large sample space whenever standard deviation sigma is not given there. Okay, so first we will find the standard error. Standard error, so this is SE equal to what? Square root of p cap into 1 minus p cap by n. So this is equal to the what? This is equal to the p cap, we have find 0.7, and this is equal to what? 1 minus 0.7 by n equal to what? 600. So this is equal to the what? This will be equal to 0.70 into 0.30 by 600, square root of 600. So whenever we will solve this one, we will get that this is equal to 0.21 by 600. So this is equivalent to what? This will be equivalent to 0.0187. Okay, so now we will find the marginal error, margin of error. So we can now we will find the margin of error. Margin of error E equal to what? Z alpha by 2 into standard error. So this is equal to the what? 1.645 into 0.0187. So if we multiply this thing, this is equivalent to the 0.0308. Okay, so now we have find the margin of error. Now apply the formula to finding the confidence interval for large sample space whenever the standard deviation is not given. Confidence interval Ci equal to P plus minus the margin of error. So P is equal to P cap, this is equal to what? 0.7 plus minus, this is what? 0.0308. Okay, so this is equal to the what? This is equal to 0.6692 comma 0.7308. Okay, so this is the interval, confidence interval. So 90% of 90% confidence interval for the population proportion is what? This is 0.6692 to 0.7308. Okay, so this is all about the problem. We have discussed three problem. In one problem, whenever the standard deviation sigma is given, and there is another problem we have discussed when the standard deviation is not given for the small sample space, and one for large sample space. Okay, so let us summarize the lectures. We discussed sampling from a finite population, difference between the point and interval estimation, definition of the confidence interval, interpretation of the confidence level. Then we have discussed some numerical examples for mean and proportion. The key takeaway in that interval estimation provide a range of value which is more informative and realistic compared to the single estimation. With this, we come the end of this today's lecture. I hope you now have a clear understanding of the interval estimation and the confidence interval. Okay. In the next lecture, we will continue with the further topic in statistical inference. Okay. And here I have given some practice problem. You will solve this problem. If there is facing any difficulty, also you can comment on the video. I will provide a solution. Okay, thank you for your passion to listening my lectures. We will meet in the next lecture. Thank you so much.